Go.
Go! Yeah, so we're still factoring because we love factoring. So it's just a different way of factoring because now we're going to have like an actual A value. And so we can't go straight to factor form. We have to work a little bit harder, but it's still not crazy horrible. So I'm just going to say use this method when A is not equal to 1. Okay, so you're still going to be given like some trinomial that's going to be in the form ax squared plus bx plus c. So now we'll actually have an A value other than 1. So when you do it, the question we're asking is what multiplies to AC but adds to B. So same question, we're just multiplying the first term and the last term together, figuring out those two factors. So when you figure it out, if I say the factors are like, I'm just going to say P and Q, then you would rewrite this whole ax squared plus bx plus c as ax squared plus px plus qx plus c. And then I'll have to cut it in half. So I'll explain that a little more when we do an example. But yeah, can't go straight to factor form. Have to write in 4 terms, cut it in half, and then we can write in factor form. AC method. Most people will forget the shortcut that we went the last 2 days and just always do this full AC method every single time.
Is that A times C?
Yeah. Yep. Okay, so our first example, we have 3x squared minus 10x plus 8. So I need to figure out first what is A times C,
P times Q or
PQ.
P comma Q?
Mm-hmm. So A times C is
Equal to 4.
right. 3 times 8, A value is 3, C value is 8. 24. The B value is 10. Okay. So it multiplies 24, adds to negative 10. Okay. So if I add 4 and 6, I get a positive 10.
Yeah.
So I need to make them both negative, because when I multiply them, I get a positive 24. Adding them, I get negative 10. So these are like acting as my P and Q right now. So before I'd write x minus 4x minus 6 and be done. But that's not going to get our first term to multiply to 3x squared. So our trinomial here is going to be rewritten. So the first term and the last term always is the same. So I write 3x squared down. This whole negative 10x is being the part that's rewritten as minus 4x minus 6x. And we can do that because negative 10x is the difference of negative 4 and negative 6. So that's why we can do that. And then I have plus 8. So basically just rewrite the middle term as 2 parts. Nothing too crazy there. So once you have it in 4 terms, I can cut it exactly in half, which is right there. So we're factoring it a little bit different. So I work with each half now that I have it like this. So just looking at 3x squared minus 4x, is there anything in common with those 2 terms? X. So I'm going to factor out an x, or I'm going to divide an x out, however you want to think about it. So what's left over? 3x minus 4 because I took the x out of that term as well. Okay? And then I look at the other half, at negative 6x and 8. What can I divide out of both of these terms? 6 doesn't go into 8.
2.
2. So I'm going to do negative 2. The first term in that sequence is negative out.
Right.
So I divide
3x plus 4.
minus 4.
Oh, yeah, sorry.
Yeah. Right. So if you did it correct, these parts in parentheses, they should be exactly identical to each other. So that's why nobody's checked. But we're not quite done yet. I still want to write in factored form. So I have one part that's 3x minus 4. But then the other part comes from the pieces that were factored out. So x was factored out and minus 2 was factored out. So that's its own set of parentheses by itself. So this is the factored form of 3x squared minus 10x plus 8. And you can still check to make sure it's actually right. 3x times x is 3x squared. Negative 4 times negative 2 is positive 8. So show you the first and last term. They work out.
That's in factor form?
Yeah. So I mean, we added 2 steps to this, to factoring, from what we were doing before. It's nothing mind-blowing, hopefully. Here's our next one. 6x squared plus x minus 16. So a times c is negative 90. And the b value. Okay. Now the two numbers that multiply negative 90 but add up to 1. Nope. If I add them, I get 91. If I subtract them, I get 89. No go. What's another option? 10 and 9. Right. I get to 19, but subtracting I get to 1. So I can make 9 negative. Okay. So then how can I rewrite my trinomial with this 10 and negative 9?
You would do 6x squared plus, right?
Doesn't matter.
Plus 10x.
Minus x. Yeah, it doesn't matter what order you put it in. You could start with 10x
That was
squared,
what I was struggling with.
negative
I'm like,
9x.
okay, wait, what's the correct order?
Doesn't matter. It'll still work out and get the same factor form. So, cutting in half, working with the first two, what can I take out?
X.
And
2.
the 2. So if I divide 2x out of both of these,
Yeah, 3x. Plus.
okay. And then the other two terms, negative 9x and negative 15.
Factor 3.
Yeah, and I'm going to do negative 3.
So that would be 3x plus.
And once again, we have these parentheses that are identical, so we know we did it right.
So then you'll have 3x plus 5. And 2x.
Yeah.
This is, I don't, wow. I like it.
Oh, good.
So then I'm not doing it. Yeah.
No, that's fine.
It's probably not doing it.
We don't have stored columns today. You're lucky.
Until tomorrow.
Oh, you guessed it. Okay.
Tomorrow, the entire section is story problems.
Yeah. So what does this look like?
How do you get the 2? Or am I missing something?
The 2x?
Yeah.
We took the 2x out of 6x squared plus 10x.
I don't I was talking about in the answer.
You take it from the 2x that's outside of the parentheses and
Square.
make it 3. Yeah, because then you have to write it. You just plug it back in.
Yep. Okay, so this one is different.
Yeah, you're missing.
We're missing that middle term. Yeah. So if you ever have a binomial, you should think like, is this a difference of squares? Which is what we did on Monday. So remember, difference of squares look like this, and we can factor it to be a minus b, a plus b. So our 81 and 25 perfect squares.
Yes, yes.
Then I have a subtraction sign. So I can write it straight in factored form. So basically I'm square rooting each
Oh,
term.
no, 9 out 5.
Yeah, so I have 9x minus 5, and then 9x plus 5. Done. Those ones are always the nice ones. We have the perfect squares.
Bam, it's done.
Done.
Yes.
Okay. This one, these are large numbers. Again, so when I multiply 49 and 64, it's super huge. But we should notice something about,
square root, they're perfect squares, so you
Yes.
can take 7 times 8.
so 49 and 64 are perfect squares. So this falls under that perfect square trinomial of a squared plus 2ab plus b squared. We could factor this to be a plus b to the second power. So this is that shortcut. Makes it really nice so you don't do the full AC method. So the square root of 49 is 7. I still have the x. Square root of 64, 8. These are all pluses, 7 to the second power.
That's it.
Yep.
That's it.
You just get rid of the 112x.
Well, I mean, it doesn't go away, but yeah. If you distribute it out, you would get out about 112x.
And then you take your square and put it outside of the parentheses.
Yeah. So whenever you see huge numbers, try and.
Like the short cash, like that's it.
Okay. I think there's 2 more. So one little extra thing. So this is 2 terms again, so it'd be nice if you could do difference of squares, but 3 and 300 are perfect squares. So can I do something first before I apply the
Then take out the 3.
Yeah, so we're taking the 3 out. And what's left over?
That is x squared minus.
Yeah. So Lincoln x squared minus 100 be factored.
X minus 100, x minus 100. Or, no, x minus 10, x minus 10. X plus 10.
Yeah.
I'm gonna get there.
X minus 10, x plus 10. Difference of squares, so you square root of them, and then I have a different sign to multiply to negative 100. So it has to be minus in addition. So that one's done too. I like difference of squares because it's like super quick when compared to AC method.
Yeah, I like, this is,
Easy method sounds
it's fun, it's easy.
Yeah.
It's like, it's for stupid.
What?
So it's perfect.
Okay, last one.
Yeah,
And
So let's finish this one.
that was good.
What should I do first?
I just,
Multiply.
and to take out something.
Yeah, let's take out like a negative 5.
Nice.
That way they're smaller numbers. So it's left over when I take out negative 5.
5y squared plus,
There you go.
yeah,
There it is.
that's what I was gonna say.
Okay. So yeah, so now inside my parentheses, none of this is perfect square, so I have to do the full AC method. So AC is 35. So what are my 2 numbers that multiply 35, add and equal?
7.
And they both have to be negative. Okay, so let's rewrite this. So you still have the negative 5 in front. I would put brackets so you know not to mess with it. But we're rewriting it in 4 terms.